For a basic understanding of Newton's second laws of motion for rotational motion as well as kinematics of the rotation, this is the best example I can suggest. Okay, and as per this example, we have a uniform rod of length 2a placed on a horizontally on the edge of a table. Initially, the center of mass of the rod is at a distance a by 3 from the edge. The rod is released from the rest. Now what we need to calculate here? We need to calculate what is the angular acceleration. That means alpha we are talking about, and the acceleration of the center of mass and acceleration of the end B. So first of all, I will go for the alpha. Once I get the alpha, then I will use the kinematics of circular motion to relate them. Okay. For alpha, I need to use the Newton's second laws of motion for rotational. That is tau is equal to I alpha. And for fixed axis of rotation, you can always use it. You don't need to worry that is it valid or not. For a fixed axis rotation, it is always valid. Relax. So right now the force is acting on this one. One is gravity, gravitational pull, mg. One is the normal force. Now you can ask, sir, how did you know that normal will act exactly at the edge? Well, very soon this will lose the contact at all other point, and this rigid rod will have contact at the edge only. And we know that normal act at a contact point. Now contact point is only at a one point, so normal will act here only. Okay. And the friction will also act at the same point, but this is parallel to the surface. And of course, it will not slide immediately, so it is basically the static friction which will act. Now, as of now, I have no idea what is the value of normal as well as the static friction, and we are not interested in this value also. So somehow I wish to eliminate them and write the equation of torque. And the best solution is I write the equation of torque or calculate torque about this point. Let's call it O. So what is the torque about point O? Due to the normal and the static friction, torque is going to be 0 because they are passing through the point O. Now because of the mg, it is mg multiply with this distance which is a by 3. It is given to us. Okay. And this torque has to be I alpha. Now the axis of rotation is basically this one. This one will behave as an axis of rotation. Okay. Which is passing through the point O. So I need moment of inertia about O, the same fixed axis, multiply with angular acceleration alpha. So what is the moment of inertia? mg a by 3, moment of inertia. It is a uniform rod, and the axis of rotation is not passing through center of mass or one of the end. If it is passing through center of mass, then answer is ml square by 12. If it is passing through one of the end, then ml square by 3. But this is none of the case, so I will simply use the parallel axis theorem. I know the moment of inertia about this axis which is passing through center of mass. This one I know, IC, and this axis is basically parallel to IC. So we can use parallel axis theorem. What is the value of IC? IC is basically m L square. What is L? L is 2a. ml square by 12. This is the value of IC. So it is IC plus md square. So it is md square. D is a by 3. So it is a by 3 square multiply with alpha. Okay. If I take m a square common, it will be nothing but 4 by 12, which I can write as 1 by 3 plus 1 by 9 alpha. On the right hand side we have mg a by 3. Now m will cancel out, 1 a will cancel out. So it is g by 3 is equal to a. This can be written as 4 by 9. So with the value of alpha, value of alpha is basically 3z divided by 4a. This is the value of alpha. Once we get the value of alpha, now the task is very easy one. For acceleration of, now it is released from rest. So what is the value of omega? Omega is 0. If omega is 0, then I know that the normal acceleration of all the points, it has to be 0. So we will have only the tangential. So tangential acceleration is equal to the total acceleration. And I know the tangential is basically r alpha, right? So all I need to multiply the radial distance from the axis of rotation. With the alpha, I will get the value of linear acceleration. For an acceleration of point C, I can say acceleration of center is basically alpha, which is 3z divided by 4a multiplied by distance of C from the axis of rotation, that is a by 3. A will cancel out, 3 will cancel out, it will be g by 4. If you are looking for the direction, then it will be downward in the direction of z, because it is moving on a circular track like this. So this is the direction of tangential acceleration, or you can say direction of total acceleration. What about the B? B will also have acceleration in a tangential direction, or you can say parallel to the G. So acceleration of B is basically radial distance. What is the radial distance? A plus a by 3. A plus a by 3 is 4a by 3, right? Multiply with alpha. Alpha is 3z divided by 4a. So 4 will cancel, g will cancel, sorry, a will cancel, and the 3 will cancel. So it's simply g. It's like B is having the free fall right now. Okay. And now the task for you to think about how we can calculate the value of normal now. Okay. This task is for you.